So today we'll be starting with the topic speed, distance and time. We'll also be covering some basic questions and some basic concepts like relative speed as well. So I'll just start with the basics first the formula and how to convert units, and then we will move on to questions of boats and streams, and then we will solve questions involving trains and their movement. So let's begin. So we know that speed is the distance covered in a certain amount of, how much distance can be covered in a certain amount of time. So that is distance upon time. Units that are commonly used are meter per second and kilometer per hour. Obviously there are more units like miles per hour and you've got more units. So meters per second and kilometers per hour. So one of the main things that you need to remember, because it is very important and will be used, is that 1 kilometer per hour is actually 5 by 18 meters per second. The way it comes is that 1 kilometer is 1000 meters upon 1 hour, which is actually 60 into 60 seconds, which is 60 minutes into 60 seconds. So you just do some basic calculations, and this is 2 5s and this is 2 3s, you get 5 by 18 meters per second. Now what can be done is that, say you have something going at the speed of x kilometers per hour, and it will be convenient to use these units. You just multiply x by 5 by 18, and this is your meters per second. So it is interconvertible like that. In case you ever end up forgetting this formula, you can always use this trick that I have picked up. You have distance, speed and time. Say I want to find say I forget the formula of speed. So I'll just cover speed, and what remains is distance upon time. So speed gives me distance upon time. Similarly, say I want to find the time, I will cover time, and I will have time is equal to distance upon speed. And say I want to find what distance is, so I will cover distance and I will find distance is equal to speed into time. So it's quite easy, the trick. So now let's move on to the concept of relative velocity using boats and streams. I'm going to use a blue for, so wait, let's assume that u is the speed of boat in still water. So still water means that velocity or speed of stream is 0, and let's assume it to be kmph, which is kilometers per hour, and v kmph is the speed of stream. We have yet to disclose the velocity, the direction here, but we're just gonna discuss the speed first. So speed of stream. Okay, now let's start with case 1. Case 1. Let's draw the stream in blue, because why not, and assume that my boat here is moving at a speed of u kmph and my stream is moving at a velocity of v kmph. Now assume you're walking at a certain speed, and somebody starts coming and pushing you from the back. Somebody comes and pushes you from the back. So your speed will naturally increase and you are able to reach your destination faster than what you would have. So this case is usually called as downstream, because when you're moving, so water always moves towards gravity, like in the direction of gravity as it pulls it down. So it is always flowing downstream. You will never see the flow being upwards, at least generally. So downstream means that your velocity is increased because your gravity is aiding that movement. All of that is not very important, but it just means that now the relative speed of your boat is u plus v kilometers per hour, which means to cover x, the distance x, it will actually now require x upon u plus v hours as x kilometers. it will now require u plus v k x upon u plus v hours, as opposed to it just being x by u if the stream hadn't been there. Now case number 2, it is going upstream. Wait, the stream, again in blue, it is going upstream. Your boat is moving upstream. I'm sorry, your stream is always flowing, but your boat is moving upstream. So it means that there is a certain push that is being imposed, but it is in the opposite direction. So imagine you are actually walking and somebody starts pushing you from the front. It will obviously reduce your speed and you are able to reach your destination in a lesser amount of time. So that would make your speed u minus v kmph. In case v is greater than u, your boat will actually now just move in this direction, and the magnitude of the speed would be v minus u. Anyway, so this is u minus v kmph, that is your relative velocity of the boat, and to cover a distance x, you will now need x upon u minus v hours. So yeah, the number of hours have increased as opposed to just it being in still water, which makes sense logically, because if somebody starts pushing you, you will obviously take a longer time to reach a certain destination. So let's move on to a problem. Okay, a speedboat whose speed is 15 kilometers per hour in still water. So u, I'll just use another color, u is 15 kilometers per hour in still water, goes 30 kilometers downstream. So let's assume the speed of the stream to be v, is speed of stream in kmph. So it is the stream is actually being traveled by 30 kilometers. So it goes 30 kilometers downstream and comes back in a total of 4 hours 30 minutes. So it actually takes 4 hours 30 minutes, which is 4.5 hours for the boat to come to its original point. So what is the amount of time that has been, so what is the speed, so amount of time that your boat will take is actually to travel 30 kilometers downstream will be 30 upon u plus v, like we discussed before, and the time it will take to come back up is 30 upon u minus v, because now it is moving upstream, so the time is also increased because it has to put in more effort, and this will be equal to 4.5. all of these are in hours. Yeah, so we know that u is 15, so 30 upon 15 plus u plus v plus 30 upon 15 minus v is 4.5. Now we can just do some simple calculation here. 30 upon 15 plus v, 15 minus v is 4.5. So we know that a plus b into a minus b is a square minus b square. So so 1 upon 225 minus v square is equal to 4.5 by 30. I have made a calculation mistake, so we are just going to re-evaluate this. This will actually be 15 minus v plus 15 plus v, and your minus v and plus v cancels out. So now you essentially have 30 into 30 here. So this is your t1 plus t2 equals t, which is 4.5. So now you have 900 upon 225 minus v square equal to 9 by 2. We're just going to cancel this out, and you get 200 is equal to 225 minus v square. Your v is now root of 25, because v square comes out to be 25 from here. Now we have considered v to be positive because we have already taken into account the direction of v when we put plus and minus sign here. So there is no need to account for the direction anymore, just the magnitude, and the magnitude is v is 5 kilometers per hour. So that is your answer to this problem. Let's move on to more questions now. So yeah, a train. So in train problems, what you need to remember is that you always have to take into consideration the length of the train as well. So you cannot be like, okay, this point crossed a certain pole, so my certain distance, so now my train has crossed the entire distance. That is a wrong mentality. You also need to take into consideration the last point. The last point will take as much distance, so the longer your train is, the more distance the train would have to cover to actually cover an entire distance of whatever, as opposed to it just being a single point. So a train running at the speed of 60 kilometers per hour crosses a pole in 9 seconds. So what is the length of the train? See, your train won't immediately cross the pole, it takes some time to cross it. So now let's just draw out a situation. I'm going to use purple. So this is your pole and your train starts approaching it. This is the initial point of the train, and then eventually your train passes it. So when the entire length of the train is covered, which is this distance, we can say that the train has successfully passed the pole, crossed the pole. So 60 kilometers per hour, as discussed, is actually 60 into 5 by 18. So 6 3s are 6, 2s are 20s are. So that's 100 by 3, and that is equal to approximately 33.34 meters per second. Now it takes 9 seconds to cross the entire train, so to cross the entire pole. So wait, this is 6 tens are, because we took 6 3s are 6 tens are, and this is actually 50, and this is 16.67 meters per second. So now it crosses the pole in 9 seconds. So we have the speed, we have the time, so we need to find the distance now. The distance will be speed into time, which is 16.67 into 9, which is approximately 150 meters. So this is the length of your train. Moving on to the next question. A train 125 meters long passes a man running at 5 kilometers per hour in the same direction in which the train is going in 10 seconds. Now the reason why I actually converted these units is because one of them is in seconds and one of them is in kilometers per hour. There is no need to do that if both the units are like matching, like there's kilometers or there's hours and there's kilometers per hour. So okay, a train 125 meters per long passes a man running at 5 kilometers per hour in the same direction in which the train is going in 10 seconds. The speed of the train is, so the concept of relative velocity also comes into picture here. So because the man is running in the same direction, the speed of the train will obviously have to be more than if he was still. So we are just going to consider the case where the man is just standing still and the train is just passing. Now 125 meters is actually covered in 10 seconds. So that means that it obviously has to cover 125 meters for the train to have completely passed the man. So this is the end of the train. The end of the train is here. This is 125 meters. So to cross the man, 125 meters in 10 seconds. So your speed will now be 12.5 meters per second. But the man is not still. The man is also moving at man's speed equal to 0. Now the man is also moving at 5 kilometers per hour in this direction. So you cannot neglect that. Let's first convert this into kilometers per hour. So at man's speed being 0 kilometers per hour, this will actually be 12.5 into 18 by 5, because we are converting it from meters per second into kilometers per hour. So that would be 45 kilometers per hour. 45 kilometers per hour. Now imagine so the train is going relatively at 45 kilometers per hour, but the man is also running at 5 kilometers per hour. So what that means is that speed of train minus speed of man is 45 kilometers per hour, because the man is making it harder for the train to cross. So speed of train minus 5 is 45 kilometers per hour. So speed of train is 45 plus 5, which is 50 kilometers per hour, and that is your answer for this problem. Now the next question. The length of the bridge which a train 130 meters long and travelling at 45 kilometers per hour can cross in 30 seconds is. So basically, let's say that this is your train and this is your bridge. So let's say that the length of the bridge is x and the length of your train is 130 meters. So when will you say the train has completely crossed the bridge? So let's say initial position would be this. This is the beginning. This is your train. This is your 130 meters long. 130 meters long, and this is your bridge, which is x meters long. So let's just assume how much. Let's just look at the distance that this point would cover. So it is also moving at a speed of 45 kilometers per hour. So now this is the initial position. This is the intermediate position, the one that I have drawn here. Final position is when your bridge has been completely crossed. So this is in fact your final position now, and the front of the train has covered 130 meters plus distance, the length of length of the bridge. So this much it has covered in 30 seconds. So it needs to cover this distance in 30 seconds. So first let's see at 45 kilometers per hour what the speed would be in meters per second. So 45 into 5 by 18, which is equal to, as we saw up there when we solved the previous question, 12.5 meters per second. Now this is 12.5 meters per second, and it took 30 seconds for the train to, so you are considering it to be able to cross the bridge in 30 seconds. So now the distance which the train would cover in 30 seconds would be 12.5 into 30, and that is equal to 375 meters. As we calculated before, your distance is also 130 plus x, where x is the length of the bridge and 130 meters is the length of the train. And this is equal to 375 meters. So now your x is simply 375 minus 130, which is equal to 245 meters. So there, your problem is solved. The maximum length of the bridge that a train which is 30 meters long and traveling at 45 kilometers per hour can cross in 30 seconds is 245 meters. Thank you.